Hi there, this is Jim. Welcome to my YouTube channel. In this video, I discussed some examples to explain more about the normal form of the equation of the straight line.
Normal form of the equation of the straight line. To illustrate this, let me draw again or sketch a line on a Cartesian plane. So let's have this as the y-axis. Okay, so there you go. This as the x-axis, right? And of course, this is the point of intersection, the point of origin. Now let's draw a line, okay, crossing the y-axis and the x-axis. Right? Let's draw a line segment from this point of origin, okay, which will be perpendicular to this line, meaning the angle formed here, of course, will be 90 degrees, right? Let's denote by theta this angle here. We can now write the equation of the line in normal form given by this equation: x cosine theta plus y sine theta is equal to p. Here, p is the perpendicular distance, so that will be the p there, the perpendicular distance of the line from the point of origin to this, of course, line. And once again, the angle theta here is the angle formed by the x-axis and this line segment with length p. Thus, this normal form of the equation of the line is useful in determining the perpendicular distance of the line from the point of origin. We'll now derive an alternative equation for this normal form of the equation of the line. The equation that we'll be arriving at will be useful in converting the standard equation to its normal form. The standard form of the equation of a straight line is given as ax plus by is equal to c, where a, b, and c are constants. Now, multiplying both sides by this quantity, one all over the positive and negative roots of this radical, which is the square root of a squared plus b squared, we'll have ax all over this radical plus by all over the same radical is equal to c all over that radical, the positive and negative square root of the quantity a squared plus b squared. Note that this radical should adopt the algebraic sign of b in the given equation. Okay? That is, if b is positive, this b is positive, then this radical must also be positive. If b is negative, then this radical must also be negative. Also, the absolute value of p, no? If you can recall, p is, again, the perpendicular distance of the line from the origin, okay, the absolute value of that length of the line segment, of course being a length, should be positive always. Here, this P gives the perpendicular distance of the line from the origin, and this will now be this expression at the left side, meaning P is equal to C all over the positive and negative square roots of A squared plus B squared. Note that the computed value of P here is positive. It means, if the computed value of P is positive, it means that the line is above the origin. On the other hand, if the computed value of P is negative, it means that the line is below the point of origin. Let's have some examples. First, we'll determine the distance of the line 3x minus 4y equals 5 from the point of origin. Right, so we can see here the line on this Cartesian plane. This is the equation of the line, and we are after the perpendicular distance of this line from the origin. This is denoted by P. Okay, so we'll be solving for this value of P, right? Now, given this equation, 3x minus 4y equals 5, the equation of the line, clearly here A is equal to 3, B is equal to negative 4, and C is equal to 5, right? Note that we need to transform this original equation of the line to its normal form for us to be able to find for the value of P, that perpendicular distance. Right? If you can recall, we need to multiply the entire equation by this quantity 1 over the positive and negative root of this radical, which is the square root of A squared plus B squared, right? Okay, so we'll first then solve for this quantity, okay? Note that the denominator of this quantity has two roots, the positive and the negative root. Well, we need to adapt that algebraic sign, which is the same as that of B. Meaning to say, if B is negative, like in this case, we need to adapt that negative sign for this radical. So that, substituting the values of A and B, this will now be equal to 1 over negative of A squared. So that will be 3 squared plus B squared, which is negative 4 squared, right? But, well, 3 squared is 9 and negative 4 squared is 16. So 16 plus 9 is 25, the square root of which is 5. So therefore, this is now equal to negative 1/5. Alright, so we'll now reduce this given equation to its normal form by multiplying the whole equation by this value, negative 1/5. Okay, so let me rewrite the equation here. 3x minus 4y is equal to 5, right? So multiplying the entire equation by negative 1 over 5, we'll have 3x over negative 5 minus 4y over negative 5. which is, of course, equal to negative 1. Okay, so this negative 1 here just indicates that the line has a perpendicular distance of 1 unit from the point of origin. Meaning to say, this distance here, right, is equal to 1, right? The negative sign again indicates that the line is below the origin. Let's have the second example. We'll find the equation of the line parallel to this line given this equation, negative 3x plus 4y equals 1, such that it is having a distance of 4 units below the point of origin. Right, so we can see here the lines on the Cartesian plane. The red one is of course the given line, and we denote it by L1. It has this equation, the given equation. We are looking here for the equation of this line L2 such that its perpendicular distance from the point of origin is equal to 4 units. Okay, so to do this, we need to capitalize, of course, on the given equation, the equation for line L1. We transform it to its normal form for us to determine the coefficients of x and y. Now we'll transform to normal form. Okay, so our first step is to transform L1 to normal form, right? So to normal form. Okay, again, to transform the equation of a given line to its normal form, we can do it by multiplying the entire equation by this quantity 1 over the positive or negative root of this quantity, which is a radical a squared plus b squared. Okay, note that the algebraic sign of this radical, the denominator, of course, will be the same as that of b in the given equation. In the given equation, a is equal to negative 3, b is 4, and c is equal to 1. So clearly, b is positive. So therefore, we should adopt the positive root of this radical a squared plus b squared. Okay, so substituting the values of a and b, we'll now have the square root of negative 3 squared plus 4 squared, which will in turn give us the square root of 9 plus 16, which is the square root of 25, which is equal to 5. Therefore, our multiplier will be 1 over 5, or 1/5, right? So we'll now proceed transforming the equation of L1 to its normal form. Okay, so may I copy the original equation here, negative 3x plus 4y equals 1. So multiplying the entire equation by 1/5, so this now becomes negative 3x over 5 plus 4y over 5 is equal to 1/5. This is now the equation of L1 in normal form. Now, we'll proceed to determining the equation of line L2. Okay. Note that if two lines are parallel, like in this case, L1 and L2 being parallel, their x and y terms should have exactly the same coefficients. Therefore, the equation of L2 in normal form is given by negative 3x over 5 plus 4y over 5 is equal to some constant. And this constant will be P2, right? But what is P2? P2 is, according to the problem, equal to 4, right? This P2 here, 4. However, the line is below the point of origin, so that value of P, which is in this case P2, must be negative. Hence, it should be negative 4. Meaning to say, this equation should be equal to negative 4. Right? Okay, so we can now multiply the entire equation. Of course, this P2 is not here, right? So we'll multiply the entire equation by, to eliminate the denominators, and to simplify, we can multiply the entire equation by the LCM of the denominators, which is 5, right? So we'll now have negative 3x plus 4y is equal to negative 20. This is now the equation of line L2. This line L2 here, colored green. I hope you learned something from this video. Don't forget to subscribe on my YouTube channel for you to receive instant notifications about newly uploaded lecture videos. Thanks for watching.